24 hours a day, 365 days a year.
高橋くん、今日初先発だよね。
Fujitsu's technology, connecting you with the weather.
Fujitsu, shipping tomorrow with you.
To efficiently treat patients anytime and anywhere. Fujitsu is setting up the e-patient record system, allowing medical facilities to share information. Fujitsu's technology, connecting you with medical care.
Fujitsu, shipping tomorrow with you.
Ladies and gentlemen, please welcome Goro Watanabe, Fujitsu Senior Vice President, R&D Center.
Good morning, ladies and gentlemen, and welcome to Fujitsu Executive Session. I am Goro Watanabe from Fujitsu R&D Center. I know that Monday morning is not the prime time of your week, but you decided to be here. You chose this session over 100 sessions, 100 other sessions, actually 98 other sessions are going on. That makes me think you're the most motivated people of all 50,000 visitors this week. So I'm honored to be speaking to such a distinguished audience. First of all, please help me understand my audience. How many people attended my executive session last year? I spoke here, same place, and same week. Thank you very much. Welcome back. This session was kind of designed to be a good sequel to the last year's session, but I made sure that everybody can catch up with it quickly. Last year, I spent a good half of my session talking about disaster and the technology, because I thought I had to. This year, I have some quick update for you. I'm showing you sets of photos taken from the same place right after the disaster and 1 year after the disaster. You can say that they did a great job cleaning up streets and towns, but they are still struggling with real issues. What do you think the real issues? Any idea? The photos are telling us the real issues. The town is clean, but clean of what? People. Debris, yes. What's a debris? It doesn't go anywhere overnight. How much do you think is a debris? How much? 100 tons, 1,000 tons, 10,000 tons, 31 million tons of debris still sitting here, and they're too much to bury or burn. And 1.5 million was washed away to the ocean. And right on the west coast of the US and Canada, we can't do anything. That's secondary disaster. Also, they are having a hard time rebuilding the community because they don't have enough budget, enough materials, enough human resources. Sadly, they lost a lot of community leaders, firefighters, volunteers, those brave people stayed until the last moment to help other people back in. Sad. And mental issues, kind of hidden issue, but it's serious. People lost their family members, children, grandchildren, and parents, grandparents, spouse. And they lost their house, cars, shipping boats, jobs, so everything. They lost everything. So it's not surprising many people are too shocked to start a new life. That's bad. High suicide rate, PTSD has been reported, and of course nuclear issues. We don't have a simple solution for them. We have not been just sitting. We formed a dedicated department to support the victims. We received a 21st Century Achievement Award from Computer World. But to be fair with other companies, many Japanese or foreign companies, individuals are still supporting the victims. So I'm changing my subject, but what I like to remind all of us is that, the victims can't change the subject. They're still facing the disaster 24/7. So we should stand by them. But don't get me wrong, they're not asking for too much help. They're working harder than we can imagine. But when we face the disaster of the scale, the victims alone can't overcome the difficulties. It's time for humans to work together. I have to spend a few minutes on today's session focus. It's easier this year for me because we had a keynote yesterday for a broader audience. How many people attended the keynote? Most of you, like I expected. That's good. That makes my job easy. And we have a technology session tomorrow. It's focused on technology. So I will focus on executive part. Actually, I designed my presentation for CIOs. I was told by Oracle that my audience will be CIO. So every one of you is supposed to be a CIO. Why are you laughing? It's one of the largest CIO meeting. It's 500 CIOs in the same room. I know better than that. You might be from engineering, sales, marketing, press, or you might be a blogger or between jobs. Just fine. Everybody has an executive part in your mind. So if you're not CIO, just pretend you are. We all like America because we have freedom to choose whatever we like. If you're not American, I will tell you what it is like. In America, we can choose what cable channel you watch. In America, we have 200 cable channels at least. 200 channels, yes. None of them is interesting, but we still have channels. And in America, we have freedom to choose our job. If only we could find a job. That's America. And before freedom, we need a choice. Without choice, it's not freedom of choice. If we have only one presidential candidate, do you call it freedom of choice? No, it's not. So in this session, I'd like to help you make a right choice from variety of choice. Unfortunately, many CEOs make a lot of mistakes because I believe there are a lot of myths which prevent you from the correct choice. You get misinformed, misled, and confused. So as advertised in my abstract, I'll be a bit faster today. But I need your help, so please think with me. Just relax and please help me. Some warm-ups. Apple started a tablet computer. Is this true? How many people think it's true? You are smart. They didn't. First tablet came out way before Apple started its business. How about this one? It's easy. Apple started iPad. This one is easy. How many people say true? How many people say no? Okay, if you attended my presentation last year, that's not true. We just started iPad business 8 years before Apple started its iPad. I couldn't find that exactly real iPad from 12 years ago. That looks like a cell phone, but this size, so it's very tablet. We are known as a good tablet company as well. So I have very cool new tablet this year. After I used it, iPad is very heavy. It's much lighter, 60 grams lighter. And it has a wider screen, you see. So everything is good with this one, Android, and it says Google Map. It doesn't. My wife still likes iPad, but it's her problem, not mine. So I'm providing you a choice. I'm not forcing you to get one, but you can brag about that. You can't brag about iPad anymore, okay? And three of you will be winning this nice tablet at the end of this session. I hope you will get one. One more myth to last. There will be no surprise prizes. 2007. Do you remember subprime crisis? Most analysts, financial analysts, economists, told us that there will be no problem. Don't worry, US is okay. And keep investing in housing and stocks, and we did so, and we lost 50% or even 80% of our value of our assets. The reason why some analysts keep making mistakes, they are good at explaining the past, what happened using the numbers. So we get convinced very often. But when they try to predict the future, they make a mistake because they use extrapolation. When it's going up, they say it's up, up, up. But they don't know when it turns around. But they don't take responsibility for their failed predictions. So I'm a big fan of analyst report. I don't really have trust on analyst report about the future. If you happen to be an analyst in this room, I know many of you. I'm not talking about you. I'm not talking about analysts who would be watching this video. I'm talking about analysts not in this room, because you are good ones, because you listen to opinions. And my guess. Next up is supercomputing. I owe you an answer to a question asked by myself last year. I asked the question, why did we install the supercomputer on the top floor of the building instead of lower floors? The answer is, this way the supercomputer is fastest on the top floor, because we need fewest pillars on the top floor. You see, like 80 years by 80 years, huge space, no pillars. This way we can place each node closer to each other using the shortest cable and even a faster supercomputer. IBM took #1 place this year. So I'd like to congratulate IBM for their hard work. You might think we were disappointed, but not as much as you would think. Because I told you last year it's a healthy competition. No computer should stay at the top for too long time. Actually, we expected IBM to be #1 by the end of last year, but it took 6 months more than we thought. I talked with Mr. Yamamoto. Mr. Yamamoto is our president of Fujitsu Group. Asked him if I can tell you, my audience, that we're determined to be back to #1 again. He said, sure, Goro, we'll be back to #1. But we just don't say when. He has a point, but it's a difficult business. Actually, we released a new generation supercomputer. It's a public page. You can check it out now. And it says, we have $1 to $1,000 solution and maximum speed 23 petaflops, which is 45% faster than IBM Sequoia. So theoretically, we are already #1 back again. We just need a purchase order. We have 500 CIOs in this room. Maybe a couple of you would want to write a check for this. I'm waiting. Next topic is today's main subject, Athena technology, Athena processor. Athena is the code name for SPARC 6410. It's the new generation, general purpose SPARC processor. If you're using a SPARC server, thank you very much, you are using SPARC 64.7 or before, which is very good, but we released SPARC 64.8 and 9 for supercomputing, and we are back to business computing is Athena. My goal in this section is I will provide short but good enough technology digest for you executives. And I leave details to tomorrow's session. If you're interested in deep technology, I encourage you to join our conference tomorrow. Design concept. I told you that this processor was designed for business computing, but actually we didn't sacrifice any supercomputing features, including floating processors, HPCAs. That means you can call it processor good for both high-performance business computing and supercomputing. That's a reason, of course. we're talking about big data these days. Is big data for business or science? Both, yes. It's both, right? So we need a super processor which can take care of big data. That means can take care of business and science, integer and floating point. This processor is it. And it's speed up, scale, and virtual machine architecture, and software on chip. Software on chip is we implemented some small software as a hardware instruction, which of course boosts the performance. Of course, silicon has limited room on it, so we picked a small number of software, which is small but frequently used. In other words, we can pick other software, or we can add more software in the future. That's a great possibility in the future. What's important is it has 16 cores, 4 times more than what you're using currently. And we have a large 24 megabyte level 2 cache, so we were able to eliminate level 3 cache. Most processors have level 3 cache, but we don't need it. And we're using 28 nanometer technology, the latest technology. That enabled us to have 3 billion transistors in one silicon, which is the largest number in the industry to my knowledge. Power 7 has 1.2 billion transistors. If you're using Core i5 or 7, that's less than 1 billion. IBM recently announced a good-looking new mainframe processor, which has 2.5 billion. The performance, 102 gigabyte per second memory, which is double the performance of the latest Intel processor. And the interconnects makes me think of supercomputing. CPU interface 14.5, which is faster than fiber channel, and memory interface 65 gig, which is 13 times faster than Eurojupiter. System on chip is interesting. We put lots of other LSIs into a single chip, which are memory controller, router, and controller, excuse me. But in history, floating point, everything has been incorporated into single chip. That made the motherboard very simple and faster, reliable, everything is okay. So we are leading system on chip company. We put all these LSIs into single chip. At the same time, we put some software, even software on the chip. Talk to you a little bit about performance. Software on chip, of course, boosts the performance. It's just the initial cut, but we make 400 times faster number operation. Number is an operation used by Oracle database. Oracle database has its internal expression, doing a lot of complex calculation each time it's used. So we can accelerate those functions dramatically using our software on chip capability. Crypto is used to encrypt, decrypt the packet whenever they are transmitted or received by your computer using SSL, TSL interface. So it runs a lot, and we can boost 160 times performance gain using this capability. SpecInt shows the system throughput. We are double the number of IBM Power 7 systems. We know that IBM will announce or start releasing IBM Power 7 Plus, maybe this week, but we can maintain the large lead after Power 7. We're looking at Power 7 Plus, we're looking at Power 8. Stream benchmark is interesting. We didn't show this slide yesterday, but stream benchmark shows that we have huge memory bandwidth. This tells us that we can transfer 5 times more memory than IBM system in a single second. I'd like to also talk about some new features on the hardware, motherboard, boxes. One is building block configuration. This is very new and remarkable. It may not look like a new feature because you have rack mount computers, blade computers, you can add computers. But that's an additional computer, it's totally different. It's a growing computer. You can introduce one block as a 4-socket, and you can grow it 8-socket and then up to 16 boxes, which is 64 sockets, which is very much supercomputer class computer. It's growing, not the additional computer, it's very much different. If you bought IBM 795, which is the largest configuration of Power 7 computer, it always comes with huge box. You have to buy a box. You don't have to with that new technology. One more feature is liquid cooling. I like to use airplanes to make it fun. T-47, P-51, the warplanes 70 years ago, they look very different. There's innovation between them. The P-51 is using a small engine, but it's faster, maneuverable, lighter. Because the engine is different, air-cooled versus liquid-cooled. The same with computers. Liquid cooling has been always good because it's stable, more effective, more efficient, compact. But you haven't seen a lot of liquid-cooled computers, right? Because it's very difficult. Only supercomputers have liquid-cooled processors because performance is the top priority. But in business, you care about TCO, things like that. So it has been difficult, but we introduced this capability into business computing by LLC technology. Nothing to do with company, okay? No limited liability company. It's a liquid loop cooling. So we made it affordable, light, and no risk. I like to show you using this real hardware on the stage. Okay, I think I'm ready. So I'd like to show you, first it's a Jupyter Spark 64-7 CPU board. It's just a CPU. I tried to bring a whole system board, it was too large, too heavy, I couldn't. So this part is called heatsink. Where every high-performance processor has heatsink on it. It's a different design. They're all beautiful. It's attached to the top of the processor with the special screws and the special glue. And it is designed to catch maximum air to cool the processor. So it's all you can go through. Sorry for the wobbling camera, it's very difficult. And in contrast to those traditional heat sinks, we introduced LLC here. Those tiny, this is a processor, this area. Those tiny black part is the pump. We have 6 pumps, small water pumps, for each socket per processor. So we eliminated that heavy metal. Actually, this is very heavy. I can call it a dumbbell. That's 5-6 pounds. But this is nothing that heavy. And those pipes are special too, special rubber. So we did 5 years actually, did test just fine. We know that it works for 10 years, no problem. It's a redundant pump. So we can lose one pump, it's still okay. So all the problem will be reported by firmware and hardware, so just fine. And the beauty of this liquid cooling is, with air cooling, okay, I'm trying to be nice. Here are fans, it's a radiator. So the reason why we call it loop, it's a full closed circuit for the water. You don't need the external water coolers outside, which is a supercomputer. With the air-cooled computer, you need to place all these processors facing the fans, so there is a limit on the design. But with the liquid cooling, we can place I better stay away. We can place those processes in a row. This way we can place those memories very close to each processor. So we can gain better latency and everything. So liquid-cooled computer is faster than an air-cooled computer because we can place memories right next to the processor. Read. Thank you very much. Thank you very much. And this model doesn't have an interconnect, which is of course also interesting. We placed the interconnect module perpendicular to each board. This way we can make the path shorter, and we were able to eliminate the backbone, which was heavy and blocking the airflow. So it's a huge, one of the most complex mechanisms humans have created. You think it's large, but it was more than double large in the past. Jupiter 7, Jupiter Spock 7. And each processor has 512 gigabyte memory. This single box has 2 kilobyte DRAM, which is very much 1,000 times more than your PC, average PC. So when we talk about big data, it's all about memory. It doesn't sound very nice, but it's memory. And Mr. Ellison talked about it yesterday. Exadata X3 has 4 terabyte DRAM and 22 terabyte flash memory. This beauty will have 32 terabyte DRAM, not flash, at the maximum. So it's 10 times more than yesterday. So it can do anything. That's why we call it general purpose. I'll be back to the slide. We showed this prototype technologies to Mr. Ellison. He was very excited. He's an engineer, so he instantly understood what's good, what's a challenge, what it means. The CEO of Oracle said, beautiful future of computing. So Athena technology is based on supercomputing technologies, but we improved it for you. We have a guest speaker, actually, before I introduce him. We have been working with the Oracle database group for a long time to make sure that this process and technology is the best fit for Oracle database. Mr. Ellison said 12C, so maybe it's okay to call it 12C. This box platform will be the best platform, definitely, for Oracle database 12C. Samantha Chatterjee will tell us more. Samantha.
Thank you, Goro-san. Wow, that is one, mean processor. Wonderful. I actually had no idea of this, wonderful liquid cooling that you have introduced in this CPU. I sort of am obviously aware of some of the other interesting features, and I'm here, everyone, to sort of, share my excitement from the database group about the Athena processor with you. Let's see. So this is a mandatory slide. Okay, so I was going to talk about a few of the interesting features that I picked up. When Goro-san and the engineers from Fujitsu came by and introduced Athena to us. The first one is, of course, when Goro-san talked about it, is software on a chip. I was equally impressed by the CPU capabilities and the speeds of the memory interconnect and the throughputs it offers us, the I/O capability and the scalability of the processor itself. So I talked about each of these items, what caught my eye and what I'm looking forward to in the next few months and years, so that we can fully capitalize on the work and the effort effort that Fujitsu engineers have put in developing this fantastic processor. So, as far as software on a chip is concerned, Goro-san already presented some very exciting numbers that he saw, that his engineers have seen with optimizing hash functions, Oracle numbers, and cryptographic functions. Now, each of these items are, as you know, pretty heavily used in the database, and I'm pretty sure this will show a pretty dramatic improvement in the overall throughput of your workload. Now, as far as the processor itself, I can't say enough about this. I'm completely at awe that there's almost 3 billion transistors. It is beyond my comprehension. And this is extremely fast CPU, 3 gigahertz, and so what I'm sort of seeing with this processor, Goro-san, is that there is going to be a tremendous amount of single-threaded performance.
Yes.
Okay. Now, coupled with that, there are 16 cores, and each of these cores have 2 threads, and therefore, I can sort of see very, very large number of processors that we can actually deploy in each of the sockets. And therefore, I can sort of see huge parallel execution capabilities, and therefore, I sort of see very, very good performance for both OLTP and DSS in this particular platform. Now, what can I say about the memory? This is really awesome, and we are sort of, as you know, working towards a lot of in-memory capabilities in Oracle 12, and throughout this conference you will hear many details about all the cool features that are being added into 12. I don't